Let's talk about ratios, rates, proportions, and percents. What's a ratio? A ratio is a comparison of two numbers with the same units. Now, we can use words to compare things, or we could use the math symbol colon. So, for example, I could say, based on this hand, we have three black cards and two red cards. So I could say three black cards to two red cards. This is using words to express the ratio. I can use numbers to represent a ratio by saying 3 to 2. Now, the colon here is what's used to represent 2. I could also represent a ratio as a fraction. So 3 over 2. Okay, an example here. In total, there are 36 number cards and 16 aces, so non number cards. Write the ratio of number cards to aces. So our ratio would be 36 to 16. Now, I can reduce this fraction or this ratio to simpler forms because both of these are even numbers. So I'm going to divide both of it by 2. Okay, 36 to 16 is equivalent to saying 8 to 8. Now, this is still both even numbers. I can reduce it some more, 9 to 4. Now, what does it mean? It means that the ratio of cards with numbers to non numbers is 9 to 4. For every 9 number cards, there's 4 aces. Okay, let's do another example. Ralph is making a bird bath. The recipe for the mixture to be poured into the mold is 12 cups of sand, 3 cups of cement, and 6 cups of water. Let's write the ratio. We want sand to cement to water. So we have 12 to 3 to 6. Now, if I wanted it in lowest terms, I know that 3 goes into all of them. So I have 4 to 1 to 2. These are called equivalent ratios. Similar to equivalent fractions, we're doing exactly the same thing. Proportion. What does the word proportion mean? Proportion just means that we have something that is corresponding in size or amount. So think about clothing. You could have different clothing in sizes small, medium, large, and the design that's on the piece of clothing is going to enlarge as you get bigger or shrink as you get smaller. Now, let's do an example here. Concentrated juice is created by mixing 2 liters of concentrate to 5 liters of water. If you had 7 liters of concentrate juice, how much water do you need? Now, right now, we're comparing concentrate to water. Let me write this down as a ratio. The first ratio that we have is 2 to 5. second ratio we have 7 liters of concentrate juice and an unknown amount of water. But because these are in proportion, we know that enlarging it would make the correct proportion. Let's set this up into a triangle, into our rectangle. The first column, we're going to put the first ratio. Second column, we're going to put the second ratio. I'm also going to sort it out. The first row is concentrate, and the second row, we're putting the value of water. So we have concentrate 2, water 5. The second one, we have a 7 liters of concentrate and an unknown amount of water. Let's write this as a fraction. So as a fraction, I'm going to take these numbers and make it into a fraction, then this number into a fraction. So 2 over 5 is equal to 7 over W. I'll use W to represent our unknown amount of water. Next, we are going to take our numbers and cross multiply. So when we cross multiply, we're taking the lower value and multiplying the upper value across the way. In our situation, we have 2 times W, that gives us 2W, and on the other side of the equal sign, we have 5 times 7, so that's 35. Next, we're going to take the coefficient. So the coefficient is the number that is multiplying the variable. Take the coefficient and divide it on both sides. So now we have 2W divided by W is equal to 35 divided by 2. Now notice that I didn't write the W, I just wrote the coefficient. So we're just dividing by the number. Now if I have 2 divided by 2, these divide out, and all I have left is 35 over 2. Throw that into a calculator, and we have 17.5. So that answers our question now. How much water do we need? We need 17.5 liters of water. Okay, so let's summarize. How did we find the proportion? First, we rewrite the ratio as a fraction. Then we cross multiplied and we divided both sides with the coefficient. And finally, we simplified. Okay, let's solve the following proportion. Let's rewrite this as a fraction. So I have 10 over 6 is equal to 15 over x. The first number came first, the second number came second. And we did exactly the same thing for our second ratio. First number came first, second number came second. We're going to cross multiply now. 10x is equal to 6 times 15. Now these brackets are just indicating that I'm multiplying numbers together. So put it into your calculator. 6 times 15 is 90. We have 10x is equal to 90. We're taking our coefficient of 10 and we're going to divide both sides by 10 now. Finally, we have x is equal to 9. Another example, we have to solve for the letter n. We're going to put the first ones on top, second one on the bottom. N over 49 equals 10 over 35. Let's cross multiply. 35n is equal to 10 times
Good morning, Chuck.
49.
At this time, we'd like to call down all.
The second side of the fraction will become 49 times 10, and we get 490. Now we're going to divide both sides by 35. And we get n is equal to 14. Pause the video now and solve these proportions on your own. The next section we have here is rates. Rates is also a comparison of numbers, except this time we are comparing numbers with two different units. So let's look at this example. If we're talking about the grocery store, I could say that I spent $12.20 for 500 grams of salmon. We have two numbers here. They're related, but there are two different units. The dollar sign to represent the dollar, that's our first unit, and the second unit we have is grams. Now we can go on to talk about a unit rate. The unit rate is when the second unit is a round number of 1. This makes it useful because if we're comparing something at the grocery store that's sold in different quantities, it would be helpful for us to have 1. Now, let's take a look at the salmon again. We can look at the unit rate, but we're going to use 1 gram instead. Just a side note here, 500 grams is equal to 0.5 kilograms. So first of all, I'm going to write this as a ratio. I have $12.20 for 0.5 kilograms. Now, if I want this as a unit rate, I'm going to create my ratio, and I want this to be 1 kilogram. Right, so let's just backtrack. What did we do? The first one, we have our original rate. The second one, we have the unit rate. So that's separating my two halves. Now for the top and the bottom, I have the money amount up top, and the bottom, we have the weight of kilograms. So I've set this up like a ratio, and I can solve it just like a ratio. We're now going to make it into a fraction. 12.20 over 0.5 is equal to x over 1. Let's cross multiply. So we have 12.20 is equal to 0.5x. Now, let's divide both sides by 0.25 so that we can make x on its own. 12.20 over 0.5 is equal to 0.5x divided by 0.5. These two divide out the 0.5s. I still have the x on the right hand side. And on the left hand side, let's pull out our calculator to get the amount. So 24.4. Conclusion here, x is equal to 24.4. If I were to write a sentence to answer my question, I could say the unit rate for salmon is $24.40 per kilometer. Now, with this unit rate, I can go to the different stores and compare the prices for the salmon. Let's find the unit rate for each situation. Now, remember the unit rate, the second rate is always going to be out of 1. Our first example, 180 kilometers, and this is in 2 hours. I want to know, we have X number of kilometers per 1 hour. Let's cross multiply. So we have 180 is equal to 2x. Let's divide both sides by 2 now. These divide out. 180 divided by 2 is equal to 90. X is equal to 90. The X is representing kilometers. So we know the unit rate is 90 kilometers per hour. Let's look at another one. $5 for 3 packages of salad. I'm going to first make this as a fraction. $5 on top and 3 packages. I want to know the unit rate. So once again, I want to know what 1 package is because package is the second unit. Now, what is the amount of money for 1 package? Let's cross multiply. So we have 5 times 1 is equal to 3x. Divide both sides by 3. So 5 over 3 is equal to 3x over 3. Put that into your calculator. $1.67. And that's a rounded answer. It would have been 1.666 repeat. So I've rounded it to the nearest cent is equal to x. So our unit rate, $1.67 per package of salad. Now, a quick note here. You'll notice that the symbol that we used, this slash, means the English word per. And we use that when we're describing a rate, especially a unit rate. Let's do another example. 100 meters in 1.6 seconds. Let's make this into a fraction. 100 meters over 1.6 seconds. Now, you might have noticed that because we've got 1 as our second unit, when we cross multiply, it works out quite nicely that it's just division. So it turns out to be the first rate divided. Now here's a shortcut. Let's do that. You can also divide the original rate. But the part that you really need to be mindful about is what units we're using. So let's just divide this using our shortcut. 100 divided by 1.6 is equal to 62.5. What's the meaning of 62.5? We know that the bottom is going to be 1 second. So that has to be the value of our first rate. The unit rate, 62.5 meters per second. Now, because second is 1 second, it's a bit redundant to write per 1 second. I'm just going to write second because it implies that it's going to be one. Right, this is a running pace. I run a lot, and often my 5Ks are around this time. So, runners like to describe their speed in terms of a pace, and you talk about how many minutes it takes for you to run 1 kilometer. Let's do the shortcut and use this. We have 33 minutes per 5 kilometers. Now, if we simplified that, 33 divided by 5, we get 6.6. 6.6, and we're going to keep the units that we have, minutes per kilometer. So we have 6.6 minutes, and that happens to be per kilometer. The pace or the unit rate for this person's run is 6.6 minutes per kilometer. Let's apply rates to a problem. A lot of rates are applied to the stock market when you look at the value of a stock over a period of time. Now, Yana Corp reported a change of negative $120 over a 10-week period. Negative 120. This means that it's losing money. The money it's worth $120 less than it did 10 weeks ago. So, what is the average weekly change? Meaning, what is the change for 1 week? So, we know unit rates. Let's make this a unit rate because we want to make the 10-week period into a 1 week period. So, negative 120 over 10 weeks. Let's divide that. Negative 120 divided by 10 gives us negative 12. So we have negative $12 per week. What does that mean? It means that each week the value has gone down by $12. Now, if this rate of change continues, how much will the stock fall in 15 weeks? We've already said we know that this is the rate for 1 week. Let's create our ratio again. So negative 12 over 1. I want to know what the value is over 15 weeks. Let's simplify by using the knowledge we have of ratios and solving this. A negative $12 times 15 weeks. 12 times 15, let's throw a negative, negative 180. So in 15 weeks, the stock fell by $180. Right, now pause the video. I want you to try 10 questions about rates.